Hello all, I'm your TA Balaji and today we will be discussing assignment 3 solutions. So we'll start off with the first question. Which of the following statement will be printed when the above C code executes? The value of max num is nothing but 2 into 3 plus 20, which is 6 plus 20, which is 26, and hence the value that is printed will be max num equal to 26. Sum equal to 26, right? When the above C code is compiled to an equivalent assembly code, which of the following statements are true? So for this question, it is better you try it out in the Godbold website. You will notice that the compiler automatically computes the value 26 and it places it on max num. So the value that is uh, basically the answer is the compiler computes the results and directly replaces the value 26 wherever maximum appears. You may verify this by executing this code on Godbold website. Moving on to question 3. Which of the following is or true? Linker combines all object files and generates an executable. Yes, this is true. If statement 1 of the above C code is removed, a compiler error is thrown. No, a linker error is thrown. Why? Because when statement 1 is removed, the printf function which is defined inside this file stdio.h is not defined anymore. Hence, there is a linker error. Moving on to question 4. Which of the following errors occur when the above C code is compiled and executed? So when this code is compiled and executed, there exists a linker error. Why so? Because the function callee_1 is being declared, however it is not being defined. Therefore we have a linker error. That is, during the time of compilation, the compiler sees that there is a valid declaration, but there's no definition for callee_1, which is not observed by the compiler. It is observed only by the linker, and hence it is a linker error. Now moving on, here in question 5, we can see that the function is now declared as well as defined. Hence this code does not produce any kind of error. But now when you look at this code here, this function callee_1 is not defined nor is it declared. Hence in the first step of compilation itself there will be an error, and hence it is a compiler error. The following C code is compiled to the unoptimized assembly equivalent and so on. So we will basically look at questions 7 all the way till question 21 that are based upon this C code, which is being compiled into this assembly code. Okay, so let's go over it one question at a time. With respect to the main function, as shown above in its local variable space, answer the question. What is the value of n0? So the value of n0 is 8. Why do you think so? That's because if you look at the main function, in the main function there are two variables. Each is of type int, and an int type variable occupies 4 bytes of memory, and again another int type occupies 4 bytes, and hence the total number of bytes is 8. Therefore, sub esp minus comma 8 is happening over here, which allocates the local variable space for the main function. So that is 8 here. In statement 13 of the above code, which translates into appropriate assembly code, the value of non-negative integers n1, n2, n3 respectively are. Statement 13 of the above code. Going to this statement, what is n1, n2, and n3 is being asked. So we know that when a function is called, its arguments are passed from right to left. Hence, these values are basically 6, 4, and 2. Yes, 6, 4, and 2. In statement 13 of the C code of the C program in main, it performs a function call as shown. After the assembly code executes until this address, what is addr underscore 1 and the value in the address pointed by ESP, right? So this. So what is addr underscore 1? So let's just look at what addr underscore 1 is. So here call addr underscore 1. So basically we are and a call operation is being performed, that is this the control needs to go to this address location, which is 0xC500. What is the value in ESP? So after the call happens, the function has to return back to a location after, I mean, the call app happens over here. So the return value should be the next instruction address. Hence 0x307 is the next instruction address, which is this. And this is the called address. Question 12. In the case of a function call, it is required to store the context of the callee when the called function returns back to the callee. With this premise, determine what reg1 and reg2 are. So what is reg1 and reg2? So basically, as soon as a function is being called, the first step is to keep track of the EBP. So push EBP is performed. So EBP of main is preserved. The second step is to move the EBP to ESP. So that is the second step. This is the prologue whenever a function is called, and hence these are the two. And hence reg1 and reg2 are EBP and ESP. With respect to surfAR function and its local variable space, what is the value of n5? So let's just look at this. What is the value of n5? Where is n5? Yes, it is n5 over here. So again, how do you calculate this? Basically, you look at what are the total number of local variables in that particular function over here. Give me here. So there are two local variables. Both are of type int, and we know from before int occupies 4 bytes and a total of 8 bytes. Hence this value is supposed to be 8. Therefore the answer is 8. With respect to surfAR, what is the value of qual? So we will look at this again. What is qual? Move qual pointer EBP minus this to 0. So what is this instruction actually corresponding to? It is corresponding to this particular statement, right? Because this value is being moved to zero is being stored there, which is exactly what this statement is doing. And we know that it is of type int, therefore qual must be dword, because dword means dword is used for 4 bytes of data, right? Hence qual is dword. With respect to this, the values of n6, n7 and n8 are. So what is n6, n7 and n8? Yes, so basically now values are being retrieved from locations. But now let's look at the stack segment. How does the stack segment look? Here we have already stored the EBP of main, and we need the EIP of ret, the return address that you need to go to, or basically you need this address, which is 0x307, which is being stored here, and the remaining data are the local are the parameters that are being passed. And in these statements there are operations that are happening with these parameters. That is, this operation is happening, right? This is being executed in these three statements, and hence they are 8, 12 and 16, because EBP plus 8, EBP plus 12, EBP plus 16, right? So analyze surf AR. What is the value of val as in the address location C50C? So let's look at C50C. C50C, shift left EAX comma val. So what is this? Basically, this is nothing but a multiply by 2 operation. So this must be 1. I'll tell you why. Because here SAR is equal to 2 times this whole thing, right? This whole thing is computed before until yeah, this whole value is computed in EAX. Now you need to perform a multiply by 2, and that can be easily performed by a shift left operation SHL. And when you shift left by 1, it is equivalent to multiply by 2. Therefore val is equal to 1. So 1 is the right answer. Yes, 1. What is the value of val 2 as in the address location C307? Let's just go to C307. C307. Yes. What is val 2? So here, since we have passed 3 variables, the local variable space, ESP, must be retrieved. Hence 4 into 3, 12 is the answer for val 2. Basically, stack cleanup is being performed over here. Four into the 12. Okay. Which of the following statements are true about surf AR from main? As we saw earlier, since stack cleanup is happening at the caller, hence the type of convention is underscore underscore cdecal convention, and in this convention the caller performs the necessary stack cleanup. Hence option A and C are the right answers. Which of the following statements are true about the C program and its assembly code? Statement in the address location C300 and 500 are used to store the context of the respective callee function. So let's look at that. 300 and 500. Yes, push EBP and push EBP. This is performed to store the context of the callee, which is in this case EBP of main, and in this case the operating system basically calling this function, or where this function starts. So this is used in the first statement, C300 and C500 is used to store the context of the callee. Statement 306 performs the task storing the return address in the register EAX. 306, no, it performs transfer of EIP from from this address to this address. That is the role of call ADDR underscore 1. So that option is wrong. Statement in the address C307 is used to perform explicit stack cleanup by the callee. So this we have seen before itself. This statement is used to perform explicit stack cleanup. Statement in the address location C302 and 502 are used to set up the local variable, set the local variable's context for its respective function. Is that right? And yes, that is right, because you look at this here, you subtract ESP comma 8, which sets the local variable space for main, and here ESP sub ESP comma N5, which is the local variable space of this guy, which is 2 variables, which is 8 bytes. Statement in the address C511 is used to restore the context of the main function. Let's look at this. C511. yes, pop EBP. So this is nothing but the EBP of main that is being popped. Hence, it restores the context of main. Context of main is restored. So that is correct. Yeah. Moving on to questions 22 and further. Before I start off, I would like to say that it would be better if you tried out this code on Godbolt website to get a feel for what is happening in the assembly when this code is basically compiled, right? So with that being said, we'll proceed. Which of the following assembly statements will be the corresponding assembly statements when statement 5 of the above code is compiled, right? So which is statement 5? So this is statement 5, and when this when this line is executed, what happens is basically the prologue of the function sub is executed. So what is there in the prologue? It just consists of the usual statements, which is push EBP, then move EBP comma ESP, setting the local variable space, and thirdly we have push ECX, which pushes uh, uh, which passes this pointer into the stack. Okay, so hence push EBP, move EBP comma ESP, and push ECX are the three statements that you will observe, which constitute the prologue of this code, right? Which of the following assembly statements, question 23, will be the corresponding assembly statements when statement 10 of the above C code is executed? So let's look at statement 10. Statement 10 is again the prologue of the main function, and in the main function, as you would guess, it would have push EBP, move EBP comma ESP, and sub ESP comma 12. So let's just look at why this is happening. Let's take a look at the stack segment. So here the EBP of the caller is being pushed, and then you have these local variables of the main function that needs to be stored, and hence you need to give it 4 bytes and 8 bytes respectively, which is Z, an integer which occupies 4 bytes, and X, which belongs to the type class CLS test, which has 2 integers which each contribute to 4 plus 4 and 8 bytes. Therefore, a total space of 12 bytes is given to this. And now ESP must now point to the top, which is ESP equal to ESP minus 12, wherein the initial ESP was over here, right? And that is what is happening here. That's question 23. Now, question 24. When statement 14 compiles, one of the assembly statements is this. Okay, what is the non-negative integer val? Okay, so let's try to understand what this is. Statement 14 is this. When statement 14 compiles, you get one of the statements is this. So let's look at it. Basically, we are trying to pass this pointer into the register ECX. Now, where should what is the address that needs to be actually stored in ECX? Let's just look at that. So we know that the variable X corresponds to type CLS test, right? And we need a way to communicate this information to the called function which is of type which is in the class CLS test, right? So the only way you can do that is you can say that this pointer corresponding to the local variables or the variables of CLS test starts over here. Okay, let me use this color. Starts over here. That is nothing but EBP minus 8 plus 4, 12. Right? So that is why your value of val is 12. And hence the answer is 12. So thank you very much. Meet you in the next assignment discussion.